Now, one important point I forgot to discuss is what is when the difference between why do we use here schedule or dispatch? Okay, schedule or dispatch. See, we have seen what is meant by scheduler, right? What is meant by scheduler? A scheduler. See, this is our operating systems program. Okay, a big program. Okay, there are lines of code and it will have a lot of functions. We have seen it in the introduction class, right? Fine. Now every function will do some kind of resource allocation function, right? Each one of them will perform something. Okay, so what is meant by scheduler and dispatcher is scheduler is a part of a function which decides which process to be executed by the CPU next, which means the scheduler takes care of something called as CPU scheduling, right? Which process should execute the CPU next. Now once it has decided the process, which means there are number of processes in the ready state, right? P1, P2, P3, so on. Okay, now whenever once scheduler has decided among these processes which process should be executed by the CPU next, actually what should be done next? What should be done next? That's my question. Okay, now let us assume out of P1, P2 and P3 which is in RAM, our scheduling algorithm has decided that process P1 should be executed next. Okay, let us assume as of now CPU is executing process P4. Okay, now P4 has to be preempted. Let us assume P4 is preempted. Now what we should be doing is, while executing P4, our CPU should have updated some registers, right? Some register values, it should have been updated. For example, 2, 3, 5, something like that. Now whenever P4 is preempted, these values has to be saved. Why are we saving these values? Because let us assume once P4 is preempted, we are actually picking process P1. Now once P1 is completed, again we might have to CPU might have to continue with P4. Now CPU might have to continue with process P4 after completing P1, right? Now while continuing P4, it needs to continue from where it left last time. Okay, now in order to continue from where it left last time, it needs to know all these values. Okay, so that's the reason whenever we are switching from P4 to P1, which we also say that as context switching, right? We store the values of these registers. Okay, so we need to save these values of registers. Okay, so before doing context switching, we need to save the values of these registers. Fine. Now these register values, once let us assume initially CPU is executing P4. Okay, now it has started with P1. Okay, now once P1 is completed, let us assume it is again deciding to start with P4. Okay, now what should have happened is these values should have been restored, right? Restored, which means initially the values were there, they were actually saved somewhere, and we were executing P1, and once P1 is completed, we are again continuing with P4, and so these values has to be loaded back into register, right? And this has been done by something called as dispatcher. Okay, dispatcher is also a program. Okay, dispatcher is also a program which is part of our operating systems code, right? Which means scheduler, after deciding which process to execute next by the CPU, which process should the CPU execute next, it will call the dispatcher function. Okay, this is also a function in OS. Now what this function will do is, this function will load the contents of register to execute further. Okay, so a combination of scheduler and dispatcher, which means both these modules of operating system are actually doing the short-term scheduler, are actually doing the CPU scheduling. Okay, so that's the reason we have written this as schedule or dispatch. Both are being used in order to schedule a process to the CPU. Okay, fine.